Okay, this is section 6.1 on solving trigonometric equations. Um, so in this section, you're going to be using basically some basic algebra skills like you have used all your life, some of them even back as far as middle school, but with the exception that instead of solving for a variable, you're still solving for a variable, but first thing you're going to be doing is solving for the trig function. So you'll be isolating the trig function just like you're used to isolating the variable. So it would be like almost like when you look at this equation, you want to treat it just like you would if you were solving 2x minus 1 equals 0. So like I said, this is a pretty elementary equation. You add 1, divide by 2, and x equals 1/2. It's just that instead of it really being x, it's really x is really sine of x. That's equal to 1/2. So you're going to add 1 across. You're going to have 2 times the sine of x equals 1. And then the dividing by 2 gives us the sine of x equal to 1/2. So now it comes down to kind of doing the reverse thing where, normally we're used to them giving us the angle and we've come up with the opposite to the hypotenuse. Now they're giving us the ratio of the two sides and we're coming up with the angle. So we know 1/2 should be kind of by now, you recognizing that that's a common angle. So I can go to my unit circle on my green sheet, or I can just think of it in terms of, what quadrants. First of all, what reference angle has a sine of 1/2? And the answer is 30 degrees or pi 6. Depends, it doesn't really specify here how. So with this first one, I'm going to kind of show you all aspects of it as far as how you would give the solution. So we know that sine is positive 1/2 when x is 30 degrees, or when the angle theta is 30 degrees. Now, in radians is pi over 6. So this would produce a true statement. Sine of 30 is 1/2, sine of pi 6 is 1/2. All right, the other place that sine is positive 1/2 would be over here. When the reference angle is 30, then the actual angle in standard position is 180 minus 30, which is 150. Or it's pi 6 minus 1 pi 6, because 30 degrees is pi 6. So 6 pi 6 minus 1 pi 6, which is 5 pi 6. So in radians, 150 degrees is 5 pi 6. Now down here, it would be negative 1/2, so we don't include these. And so I could say that x is equal to 30 degrees and 150 degrees, or in radians, we would say is equal to pi over 6 plus 5 pi over 6. Now, here's the thing though. 30 degrees is a solution, or pi 6. But so is if I go to 30 degrees and then I go all the way around the circle and back to 30 degrees. In other words, if I add 360 to this 390 degrees, that's a solution. If I add 360 again, every time I land on this, because these functions are cyclic, so once you go all the way around and you land on that spot again, every time it's going to have a reference angle of 30 and the sine's always going to be 1/2. So if it's 30 degrees or 390, or, if you continue to add 360, you're going to get infinitely many different solutions. Different angles that are solutions. Same thing here. So if it asks you to express all the angles, so these are basically the angles that fall between, or in degrees, these that fall between when x is greater than or equal to 0 but less than 360, or in radians, saying that would be to say it's greater than or equal to 0 but less than 2 pi. So when they ask for it this way, that means to give just the angles that are solutions that are within the first rotation from 0 to 360. But if it says list all the angles, then here's how we do that. So we say 30 degrees. So 30 degrees would be a solution, but so would every time I add a multiple of 360 to that. So k would just represent any integer. So 360 times 0 would be 0. So that would be 30 degrees plus 0. So 30 degrees, that's a solution. K is 1. That's 360. 30 times 360 is 390, so that would be the one you go all the way around and land there. And then if you add 360 times 2, 720, that's 750. That would be another solution. If I put -1 for k, that would be negative 360. 30 minus 360 would be negative 330, which would be this angle still lands there. So that represents all of the possible solutions. And then this is 150 plus 360k. And that would represent not just this angle, but every time you go around the circle and you land on that spot. And then, of course, in radians, it would be, you would write that as pi 6 plus 2 pi k. So 2 pi is this equivalent of 360, and 5 pi 6 plus 2 pi k. All right, and so those are just two different ways. It depends on what they ask for, how they ask for the solution. So this is if they want all solutions. And this is if they just want the solutions between 0 and 360. Also, remember, you could, if you just look at it just from a graphical, and they're not going to ask you to do this, but just to kind of tie this into the graphing, if you were to graph the sine of x, so remember, sine starts at 0, it ends at 2 pi, so it goes from 0. If you split the period into 4 equal parts, from 0 up to 1, down to -1. So 0, 1, back to 0, down to -1, and back to 0. And all right, so this is the graph of y equals sine x. And then let's look at the graph of y equals 1/2. All right, so when does the y equals sine of x equal 1/2? That's what we're trying to find. When does sine of y, when does the sine of x equal 1/2? Well, they equal here and here. And that would be at pi 6, and that would be at 5 pi 6. So graphically, that's what you're looking at in the same, just a kind of a graphical view of what's going on here. Okay, let's look at another one. All right, so this one, so this time we just want the solutions between 0 and 360. We want to be in degrees because it's given in degrees. And we just want the first rotation, so we don't have to worry about the 360k thing. So I'm just going to take the function 3 cosine x minus 5, or the equation, and I'm going to solve for the cosine of x. So I'm going to solve for the trig function, just like this is my variable. So we're going to add 5. So that gives us 3 cosine x equals 5. And then I'm going to divide by 3. And I'm going to get cosine x equals 5 over 3. All right, so with this one, a couple things. If I were to inverse cosine of, because this is not a common angle, this is not one of our, not one on our circle that we have to memorize. This is one we would use a calculator for. But I don't even really need to use a calculator because remember that sine can't be bigger, cosine and cosine can't be bigger than 1. This is actually equal to 1 point, it's 1 2/3, which is 1.6 repeating. So this is not possible. Remember, cosine can't be bigger than 1, and that would be like, be like saying that the adjacent side is bigger than the hypotenuse. And we know in a right triangle, the hypotenuse is always the biggest side. So if you put this in a calculator, inverse cosine of 5/3 to figure out what the angle is, your calculator is going to say error or something, domain error or something like that. Because the answer is there is no solution. There's nothing that's going to make that true. And so that one's pretty simple. We don't have to do any more because there is no answer to it. All right. All right, so this one says find all degree solutions. So we're looking for all solutions this time. So this is going to have to, we're going to have to represent the 360K thing on this one because it's all solutions, but it is in degrees. So we want to just do it in degrees. All right, so we have the sine of the angle. So this a minus 60 degrees here is just, this is my theta. This is my angle. This whole thing is. So sine of what equals negative square root of 3 over 2. Now, this should ring a bell. This should be a familiarity because we know that square root of 3 over 2 is a common angle. So we will use our circle. We'll give exact answers, no calculator on this. So for what angle does the sine equal negative square root of 3 over 2? So first of all, sine is negative down here in quadrants 3 and 4. So we're going to be in quadrant 3 and 4. So is it 30 or the 60? And the answer to that is it's the 60. So a 60-degree angle, reference angle down here, and a 60-degree reference angle down here. So we want to give the angle in standard position. So this would be 180. Let me erase my quadrant marks. Get those out of the way so they're not right over top of them. All right, so this is 180 plus 60, so this would be 240. And this is 360 minus 60, so this would be 300. So I have, so now that's what the theta would have to either be 240 or 360. So sine of 240 is negative square root of 3 over 2, and sine of 300, not 360. Sine of 300 is negative square root of 3 over 2. So both of these. Now, we want to solve for a, though. This is what the whole angle has to be, 240 or 300. So we need a minus 60 to be 240, or a minus 60 to equal 300. So if I add 60 over, that means a would first have to be 300, because once you plug it in here, 300 minus 60 would be 240. Sine of 240 would then be negative square root of 3 over 2. Here, if I add a 60 over, I get 360. So a would be 360, but when I replace a with 360, 360 minus 60 is 300, and sine of 300 is negative square root of 3 over 2. Now, that's just given the first rotation of angles, so I want to make sure I not only are those solutions, but any multiple of. And be sure you always put the degree symbols, because you probably will, WebAssign will probably count it wrong because it will assume you mean radians if you don't type the degree symbol. So even here. Now with this one, if you recognize that, here I'm at 360. Okay, well, every time I add 360, I really could take this off and just say 360K, and that would cover it. That would be the same thing as saying 360 plus 360K. If K is 0, then it's 0. 0 is a solution. It's here. If K is 1, then it's 360, so it's here. K is 2, it's 720, so it goes around twice and lands there. 3 times lands there. K could be negative 1 and be negative 360 and still lands there. All right, so that would be two solutions, 300 plus 360K and 360, or any multiple of 360. All right. Number 4. So this one, we're looking in radians this time, but we just have to worry about the first rotation of angles. So no, we don't have to list all of them this time. All right, so let's look at the equation. So 3 minus 7 times the cosine of x minus 2 equals 8. All right, so remember, we're focusing, this is our variable right here. So we're just trying to solve for the cosine of x minus 2. So I'm going to subtract 3. So I have negative 7 variable equals 5. 8 minus 3. All right, and then I'm going to divide by negative 7. I get cosine of x minus 2 equals negative 5 over 7. All right, so now think of this as my angle right here. This is my theta. Cosine of what equals negative 5 over 7? All right, the answer is I have no idea. It's not one of my common angles. I'm not going to know that one by heart. I'm going to use a calculator. All right, so I can either use I've got a calculator here. I could use my online calculator. All right, so I have the Desmos calculator pulled up here, and I typed in just the inverse cosine. Oh, I did inverse sine. I need cosine. Inverse cosine of -5/7, and it is 2.37. I'll just carry 2 decimal places. 2.37. So 2. All right, so the angle theta, which is x minus 3 right now, or x minus 2, is 2.37, or theta could be, oops. All right, not sure what's going on with that. All right, so let's draw it out here. So 2 points. So this is where it gets a little, because we're not really that familiar with, we're used to seeing pi if it's in radians. And so when it doesn't have pi in it, we kind of get a little stuck on where to go. So let's just think about the circle here. So this is 0, and this is pi, and this is pi halves. So this is what separates the quadrants, and this is 3 pi halves. So we got 0, 1 half, 2 halves, which is 1, 3 halves, 4 halves, which is 2 pi. So if you were to take, well, we know that pi is approximately 3.14 radians. So we know that 2.37 falls on before you get to this point right here. All right, and if you take pi divided by 2, half of 3.14 is approximately 1.57. And then if you did 3 pi divided by 2, it's approximately 4.71. And then 2 times 3.14 is 6.28. So that kind of helps give you some markers. So now when you're looking at, where would this angle 2.37 be? Well, we know it'd be in quadrant 2. So somewhere in here is this angle that is 2.37. And that has a cosine of -5/7. We know cosine's negative in quadrants 2 and 3. So there should be the same angle down here that has the same reference angle that would also have to be a solution to this. So what I need to do is I need to figure out what this reference angle is, and then I'll know what this, I know it's 180 or pi plus whatever the reference angle in radians is here. So how can I figure out what the reference angle is? All right, well, let's think about this. So we know that it's pi radians, it's 3.14 radians to here. It's 2.37 radians to here. So what I need to do is I need to take 3.14 pi and subtract 2.37 from that. And that's how many radians this reference angle is going to be. So let me just do pi, calculator here. I have pi minus 2.37, which is 0.77. So this reference angle is going to be 0.77, which means this reference angle is going to be 0.77. So the other angle in quadrant 3 that has a cosine equal to -5/7 would then be pi plus. So this angle here is going to be pi plus 0.77. So it's pi plus 0.77. And that is actually going to equal about 3.91. So, all right, so there's 2 angles, and it just wants the ones. Now remember, that's what the whole angle is. I can't forget that it's really not theta, it's x minus 2 that I want to find. So it's x minus 2, let me get this word or out of the way. So it's x minus 2 that is equal to each one of these. So x then would equal 2.37 plus 2, which would be 4.37. And here x would be 3.91 plus 2, so it'd be 5.91. All right, so now if you think about it, if you put your 4.37 back in, subtract 2 from it, you get 2.37. The cosine of 2.37 is -5/7. You put 5.91 in here, subtract 2 from it is 3.91. The cosine of 3.91 is negative 5.7. So you could check that. You could easily check that on the calculator and see if those are equivalent. All right. Solve for t between 0 and 2 pi. So again, we're in radians. I know that because this is giving me the boundaries in radians. And I want to solve 2 cosine t minus 3 equals 5 cosine t minus 2. All right, so if you were looking at this as 2x minus 3 equals 5x minus 2, nobody would have a problem solving this, and you do it the same way. We're solving for the cosine. So we would get our x's on the same side, so we'd probably subtract 2x over, or maybe 5x over. Same thing, I'm going to subtract 2 cosine t off this side, subtract 2 cosine t on the side. All right, so I have negative 3 equals 3 cosine t minus 2. All right, so at this point I have negative 3 equals 3x minus 2. So then I'm usually trying to isolate x, the variable, so I'm going to add 2 to both sides, and I would have this, and then I'm going to divide by 3, and I would have this. So x would be negative 1/3. So same thing, it's just that we're solving for the trig function. So that's gone. I have 3 cosine t equals negative 1, divide. So cosine t equals negative 1 over 3. All right, now, that's not a common one. We don't know where cosine equals negative 1/3, not off the top of our head. I would have to use my calculator, so I need to inverse cosine. Let's figure out where that falls. So I know cosine's negative in quadrants 2 and 3, so it's going to be some angle here and here. So let me click over here and inverse cosine of negative 1/3. And I get 1.91. All right, so this angle is 1.91. Remember, this is 1.57 right here, so that puts me into quadrant 2, which is where it should be because that's where the cosine's negative. And that would make the reference angle here. So I'm going to go find my reference angle. So this would be pi, because it's pi here. So pi minus 1.91, which is going to be pi minus 1.91 is about 1.23. So this little reference angle is 1.23. That means this angle is 1.23. And so this is going to be pi plus 1.23. And that is 4.37. So I have two solutions. T is 1.23 and T is 4.37. And again, this is in radians. And also, I didn't say this, I should have. Be really careful. You know, if you're wanting your answer in radians, when you inverse cosine of negative 1/3, make sure whatever calculator you're using is in radian mode, because otherwise you're going to get the angle. You're going to get the wrong angle because it's going to be in the wrong. It's going to give you degrees if you're in degree mode. And if it wants it in radians, it's going to be wrong. So make sure you watch your mode. If you want the angle in radians, calculator's got to be in radian mode. If you want the angle in degrees, the calculator's got to be in degree mode. All right, so these were radians, 1.23 radians and 4.37 radians. All right, we got two more examples here. So we're getting into ones that are a little bit more, algebra is a little more involved on these last two. Just meaning that they're quadratic, so you're going to have some factoring and stuff to do possibly. All right, so this one says find all solutions. That means, oh, no, it doesn't. I'm sorry. Find all solutions for x. Okay, so it does, jump the gun on that. So it does say between 0 and 360. So we get to do it in degrees. So let's look at the equation. 2 cosine squared theta plus 3 cosine theta equals negative 1. All right, so if I came over here in my little bubble and I just think of this as 2x squared plus 3x equals -1, could you solve this? All right, well, hopefully you could. It is pretty standard quadratic equation. It's got the highest power being a 2. That tells me it's quadratic. With a quadratic equation, most of the time you want everything on one side equal to 0. And then you usually try to factor it first. That's usually going to be the easiest route to go. Sometimes it doesn't factor and you have to use a quadratic formula, but if it'll factor, that's going to be a lot faster. So let's add 1 over. Let me just kind of go through how this works without the trig function in there. So if I add 1 over, it's going to be +1. It's going to leave 0 here. And then let's factor it. Let's see if it'll factor anyway. So we'll split the 2x squared into 2x times 1x. That's 2x squared. 1, there's really no choice. 1 splits into 1 times 1. The signs have to be the same in order to get them to equal, to get them to be a +1, they have to be plus plus or minus minus. And to get them to equal a plus 3x, they need to both be positive. All right, and so if I set each, so at this point, remember when you have two factors that multiply to equal 0, that can only happen if one of them is 0. So we would set 2x plus 1 equal to 0, because if this factor equals 0, it doesn't matter what this one is. Anything times 0 is 0. So if this is 0, 0 times anything is 0. So if this one's 0, it's a solution. Whatever makes this one 0 is a solution. So if this equals 0, it doesn't matter what this number is, because as soon as you multiply this by 0, you get 0. So if either one of these is 0, so we set each factor equal to 0, and we solve to find out what makes this 0. So I'll subtract 1 over and divide by 2. So one solution would be -1/2, and the other would be x equals -1. Now that's the same thing we're doing over here, and I'll erase this in a second if I need the room, is we're gonna, let's bring the -1 over, just like we did the first thing on in the bubble, is get everything on one side equal to 0. So we'll add the 1 over. And then we know it factors because it did here, so it's the same thing. I'm going to factor it. It's going to factor the same way. It's just instead of an x, it's going to be a cosine theta. So I'm going to split 2 cosine squared into 2 cosine times 1 cosine. And I'm going to split the 1 into 1 times 1. Both signs have to be the same, or they won't equal a +1, so plus plus or minus minus. So to get them to equal a +3, when you combine the outside and inside, both have to be plus. All right, so as soon as I have two numbers multiplied by 0, that can only happen if one of them is 0. So what value of theta would make this one equal 0, and what angle for theta would make this one equal 0? All right, well, this one would be 0 if cosine theta is -1, so I'm subtracting 1 over. Here I'm going to subtract over 1 and divide by 2. All right, and so now I just have to figure out for what angle in degrees, what angles give me a cosine of -1 or a cosine of -1/2. So this is where you can go. Now cosine equals -1/2, that is a common one. So that should trigger you to think, oh, I need to go to my circle because I can, that's one I know. I can give an exact answer for it, so I'm trying to say. I don't need a calculator for that one. So let me get some of this out of the way so I have some room. All right, and so I'm going to draw my circle here in a second. If you've got your green circle on your green sheet, you could just look it up on that. But it gets down to the point where you really, when you see 1/2 square root of 3 over 2, square root of 2 over 2, any of those common ones, you want to start to, just because they come up so often, it's worth just memorizing a few of them anyway. Just if you know those 30, 60, and 45 again, you get all the rest of them automatically. Those are reference angles for all the common angles. So when I draw this out, let's do this one first. So where does cosine equal -1? So cosine, it's 1, 0 here. So remember, cosine's your x, so it's +1 here. Well, it's -1 here. So the answer is at pi. So this is going to happen when theta is pi. So there's one solution. All right, where does cosine equal -1/2? Well, cosine equals -1/2 when the reference angle is 60 degrees, but it's -1/2 in quadrants 2 and 3. So it's a 60-degree reference angle there and a 60-degree reference angle there. So this would be 180 minus 60, so this would be 120. This would be 180 plus 60, which would be 240. So this would be true when theta is 120 or 240. All right, so there's 3 solutions to that. And again, the good thing about these equations is you could take every one of these one at a time and plug them back in for theta. If you took the 120 and you did the cosine of 120 and you squared it and you multiplied it by 2 and you added 3 times the cosine of 120 and you should get -1. If you don't, something's wrong. So it's one good thing about it is you can always check your answers. You'll know if you're right. All right, last one. So this one we're looking for in radians, just the first rotation of angles, so we don't have to do the plus 2 pi k or anything in this one. All right, so this one's already got everything on one side equal to 0, so good. So my first instinct is to try to factor it. So, think of this as 2x squared minus 1x minus 2. Is that factorable? And as I try it, let's see, if I split 2x squared into 2x times x, and this one has to split into 2 times 1, if I put the 2 there and the 1 there, I'm going to get 4x and 1x. That's not going to give me 1x. If I put the 2 here and the 1 here, then I'm going to get 2x and 2x, and that's still not going to equal. So, and there's no other options for this one. So this one is what we call prime. It's not factorable. It's already broken down as much as it can be broken down. So that is not going to work. So what do you do with a quadratic equation when you can't factor it? The answer is you use the quadratic formula. And that's what we'll do. So we are going to solve this using the quadratic formula. So again, that's one of those things that you should know, but if you need to look it up, you could. So it is x equals -b plus or minus square root of b squared minus 4ac all over 2a. That's the quadratic formula. So remember, a is always the coefficient of your quadratic term. B is always the coefficient of your linear term, and C is always your constant. So we have A, -2, we have B, -1, and we have C, -2. No, I'm sorry, A is not negative, A is just 2. All right, so let's just pop those into our quadratic formula and crank out the answers here. So we got x equals -b. Okay, b is -1. Plus or minus the square root of. So b squared, so -1 squared minus 4 times a, 2, times c, -2, all over 2a, 2 times 2. All right, so then it's just a matter of simplifying this. All right, so minus a -1 is 1. All right, let me simplify what's under. This is called the radicand, remember. It was called the discriminant. So -1 squared is 1. So I'm going to go ahead and write it down. And this is going to be -4 times 2 is -8. -8 times -2 is going to be +16. So it's going to be 1 plus 16. So why don't I just go ahead and make that 17. Save myself a lot of writing there. All right, so 1 plus the square root is 17. And that's all over 2 times 2, which is 4. All right, so now it's not x. That's if I'm doing it, if this were just 2x squared minus x minus 2, but it's not. So this is actually, x is actually the sine of t. So sine t. That's equal to this. All right, so I will need to find out what angle produces this. Well, let's figure out what this value is in decimal form first here. So let me put this in my calculator. So we've got 1 plus the square root of 17 and that's divided by 4. So I get 1.28, so that means this whole thing is equal to, well, there's 2 answers, so I'm going to do it like this. So I got the sine of t equals 1 plus square 17 over 4, which is 1.28. And then the other option is the sine of t can be 1 minus square root of 17. And then divide that by 4. We get negative 0.78. All right, and so now we can find, now on this one, so when you see this, red flag should hit, because remember, sine can't go bigger than 1 or smaller than negative 1. So that would mean that the opposite side was bigger than the hypotenuse. That's not possible. So there's nothing that makes this one true. Now on this one, I have to go to my calculator. So let me just Desmos it. So inverse sine of negative 0.78 is what angle? Inverse sine. Let me just clear the whole thing out here. Inverse sine of negative 0.78. It's negative 0.89. So jot that down. So, negative 0.89 would be somewhere in this quadrant. Reference angle is 0.89. So it's negative direction, so it's this way. And remember, this is 1.57, so if you're going this way, 90 degrees is 1.57 radians. So it's not enough to put you into the next quadrant. So you're going to stay in a negative direction. You're going to be staying in this quadrant. So the other place that sine is negative is over here. So that means it would have to have a 0.89 reference angle over here. So to give the whole angle, it has to be pi plus, this is going to be pi plus 0.89, which is going to equal 4.03. So 4.03. So t could equal 4.03. Now, instead of saying negative 0.89 this direction, we want to go this way with it. So we would want to say this angle in positive direction would be 2 pi, that's all the way around, minus 0.89. So we would take all the way around 2 pi, subtract 0.89 from that, and it would give us from here to here. So it's all the distance around minus the reference angle gives us this. So 2 pi minus 0.89 is equal to 5.59. So this angle, let me do this, would really be in a positive direction, 5.59. So you got 4.03 and 5.59. All right, and again, plug them back in. If you're not sure, 4.03, take the sine of that angle, that's in radians, times square it, times 2, subtract 4.03 and subtract 2. If you don't get 0, something's wrong. Same thing with 5.59. So you can always check these. So again, here I think of this as like 2x squared minus x minus 2 equals 0. It didn't factor, so I had to use a quadratic formula. So there's my a, there was my b, whoops, negative 1 is my b, and there's my c. Pop this in the quadratic formula. That's what x would equal if it were this, but it's what the sine of t would equal here. 1 plus square root of 17 over 4 was 1.28. 1 minus square root of 17 over 4 was negative 0.78. This one's not possible. No angle is going to give you that. There's 2 angles that give you a sine of negative 0.78. They're not common angles that you're going to know, but you can use the calculator to find it.